this is the type of question you can expect on your final exam. It will be like this, only it might not be an electron, and it will definitely not be headed that way. But this is always going to have the same magnetic field because it's the Earth magnetic field. And I can't change that. It's always going to point towards Canada and down 70 degrees. And so if I know the speed at which that electron is traveling, and the strength of the magnetic field here in Bozeman is about half a Gauss, or 5 times 10 to the minus 5 Tesla, I would just plug into this formula. Now, using this formula is trivial except for one thing: the angle. These problems are always about figuring out what that angle is. So in this case, what angle would I want to put in for theta? And it's not 20.
90 minus 20.
90 minus 20, it would be 70, okay? It's always going to be the angle between the two important vectors, the velocity vector and the magnetic field vector, okay? And so I would put 70 degrees in here. Notice that even though it's an electron, I didn't put a negative 1.6 times 10 to the minus 19 coulombs. I'm just looking for the strength of the magnetic force, the magnitude. So I use the absolute value of the charge and just get the number that no one in the room cares about. Now that looks like a really, really small force, and it is. And you'd be tempted to just ignore it and say, well, that's just too small. But it's acting on an electron that has a mass 9.11 times 10 to the minus 31 kilograms. So that force is going to cause a huge acceleration. By huge, I mean enormously huge. And what direction would that force be pointing? What's that?
Into the board.
Into the board? Reach in the direction of the motion. Turn your wrist so that you can wave in the direction of the B field. That gives you into the board for a proton, out of the board for an electron. So the answer would be out of the board. Out of the board. Now, I just told you, your particle won't be going that way. What if your particle was going due south and parallel to the floor? What angle would you plug in for theta here? Talk to your neighbor. Which angle would you plug in for theta there? Did you get 110 degrees? Okay. That's where the pipe cleaners come in handy. Or you can use your arms. If velocity's that way and the magnetic field's that way, you want the angle between them. Okay? Now, this angle here is 90. This angle there is 20. So 90 plus 20 is 110. Okay? Semaphore.